Okay, hello and welcome to NOAA's National Ocean Service Science Seminar Series. My name is Tracy Gill. Today is the first seminar of an 11-part series I am co-hosting with Katie Reeves, the Engagement and Communications Lead at the National Coordination Office of the U.S. Global Change Research Program. I will provide a few webinar logistics, and then Katie will provide some background for the series and introduce the seminar and the speaker. The presenter today is fine with clarifying questions during the seminar.
Yes.
Yes. Please type them into the chat box, and he may answer them right away or wait a little bit. And if you are interested in getting a PDF copy or recording of today's presentation, we will list relevant websites in the chat box where you can find them. Or you can contact me, tracy.gill at NOAA.gov, or Katie Reeves, and we will be happy to send you a copy. If you are not on NOAA's weekly science seminar email list, but you would like to be, please email me at tracy.gill at NOAA.gov, and I will add you to the list. Folks in the room, please in and silence your phones. And now I will hand it over to Katie Reeves to introduce the seminar title and speaker. Katie?
Great. Thanks, Tracy, and thank you to NOAA for hosting us. Good afternoon, everyone, and thank you for joining the first installment of our webinar series focused on the findings of the 4th National Climate Assessment. My name is Katie Reeves, and as Tracy said, I'm the Engagement and Communications Lead for the U.S. Global Change Research Program, or USGCRP. For a bit of background, the Global Change Research Act of 1990 mandates that USGCRP assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. One way that we do that is through the development of a quadrennial national climate assessment. The 4th assessment was released in 2 volumes. The first, the Climate Science Special Report, was released in November 2017 and covered in an earlier webinar series, which can be found on our website, www.globalchange.gov/engage/webinars, and I will share that in the box soon. The second volume, Impacts, Risks, and Adaptation in the United States, is the focus of this series. As the title indicates, NCA4 Volume 2 assesses the observed and projected impacts of climate change across the U.S., covering 17 national-level topics and 10 regions. The assessment was released in November 2018, and you can read and download it at nca2018.globalchange.gov, and that link is already in your box. Today, I'm pleased to introduce a good friend of our program, Ben DeAngelo, and his presentation, Impacts, Risks, and Adaptation in a Changing Climate, an overview of the 4th National Climate Assessment. Ben has over 20 years of experience bridging science and policy for the stewardship of the global environment. He's the Deputy Director of the Climate Program Office within NOAA's research arm, where he's been since 2017. And he serves as the U.S. head of delegation for the Arctic Monitoring and Assessment Program, a working group under the Arctic Council. Prior to joining NOAA, Ben had an 18-year career at the EPA, working on climate change and stratospheric ozone depletion. I had the pleasure of working with Ben during his days as the Deputy Director of USGCRP and Special Assistant for Climate Change to the President's Science Advisor. Ben served on the Federal Steering Committee for Volume 2 of the 4th National Climate Assessment and was an author on Chapter 29 of NCA4, Reducing Risks Through Emissions Mitigation. Thank you so much for joining us for today's NOAA Science Seminar, Ben. Take it away.
Great. Okay. Thank you, Katie. Thank you, Tracy, for that introduction. It's a real pleasure to have this opportunity to kick off this 11-part webinar series and to provide you all with a broad overview of the 4th National Climate Assessment, or NCA4. A large number of people were behind this effort, about 300 or so fed and non-fed participants. So I've got a responsibility here to represent well this 30 or so chapter assessment. Let me define something up front, and that is, what is an assessment? We use that word a lot, but it can mean different things to different people. So here, by assessment, I mean an assessment that pulls together and synthesizes numerous existing studies in scientific peer-reviewed journals and government reports. And it was the job of the authors to ensure that what they were reviewing was the most recent relevant literature, that they were being comprehensive, at least as comprehensive as possible, and making summary conclusions that fairly and accurately represented our state of knowledge. And here, state of knowledge in the various wide-ranging topics covered by NCA4. So NCA4 is by no means the result of any one model, certainly not the results of one study or even a small number of studies. But of course, within the assessment, you will find many highlights of single study results. Some of those single study results are, of course, carry more weight than others and have greater influence than others on what the overall findings are. And that was the job of the authors, to go through that literature and place the appropriate weight on individual studies. Okay, next slide. So what's the driver behind all of this? Katie mentioned some of this in her introduction. I mean, why do we do this report? The short answer is because we have to. There is a congressional mandate rooted in law. And this started USGCRP. So the US Global Change Research Program started as a presidential initiative in 1989, and then became law through the Global Change Research Act of 1990. That law, by the way, passed the Senate 100 to 0. I see some surprised faces in the room. That's true. So this act established the 13 agency member USGCRP with a mandate to, again, as Katie mentioned, to, quote, assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. And it also, in the next slide, so the Global Change Research Act also mandates this assessment, quote, not less frequently than every 4 years, to integrate, evaluate, and interpret the findings of the program, and analyze the effects and current trends of global change for the subsequent 25 to 100 years. So I want to underscore that the act itself explicitly mandates that the assessment do these future projections over 25 to 100 years. So that's an example that where the congressional mandate prescribes what the assessment focus on. But we also have to do some other things according to the mandate. We must also address the effects of global change on the following sectors that are listed here in the slide: the natural environment, agriculture, energy production and use, land and water resources, the transportation sector, human health and welfare, and biological diversity. But of course, we do have discretion to do additional things. And as I'll point out, we used that discretion in NCA4 to respond to where there was evidence and feedback, where there's a large appetite for additional information, and that is at the regional scale. We also added some new topical chapters in response to feedback that we got after publication of the last National Climate Assessment, NCA3, which was delivered in 2014. And I'll be showing some highlights of the regional work and the new chapters. Okay, the next slide. Okay, so here's a slide showing the overall structure and the context for NCA4. I mentioned that NCA4 was, you all, we've mentioned that NCA4 was carried out under the auspices of USGCRP. That's indicated here in middle blue box on the left side. USGCRP has essentially a board of directors, the principals. These are representatives from each of the 13 member agencies. That's the SGCR in that blue box, the Subcommittee on Global Change Research. Those are essentially the board of directors. And this board, in turn, falls under the White House-led National Science and Technology Council, indicated there on the left side as well. So this board of directors appointed agency representatives to serve on what we call the Federal NCA4 Steering Committee. This is the middle large orange box. So this steering committee was the primary body responsible for NCA4. This was led by David Reedmiller, who is the NCA director, and I also served on this steering committee as the vice chair. So we in the committee in turn put out a call for and nominated different tiers of authors. Those authors had different responsibilities. We also had review editors whose job it was to ensure that all comments we got were adequately
Hi, sorry, this is Katie. Tracy, I'm not sure if you can hear me, but we seem to have lost sound on our end. Hi, everyone, this is Katie. It looks like we might have lost the host temporarily. My sincere apologies. We're working on getting this all set back up. Thank you for your patience.
Hi, folks. We were disconnected. Sorry about that. Sorry we had to jump back in. We'll just give everybody a chance. Katie, are you there? Mona has raised her hand. Mona, can you type your question into the chat box, please?
Tracy, I'm here. I'm not sure that they have access to the chat box.
Oh, can you try and type in it, Katie?
I have done so, but I'm a presenter.
You just typed in it now? Okay. Could one of the participants please type into the chat box for us? Okay, Katie can hear us. Hi, Barbara. We don't have, you can't give us audio, so you can type it in.
Maybe people asking about what happened to the presentation.
At tracy.gill@noaa.gov. Oh, who's that? I don't even know who that is. Hi, folks online. It might be somebody. Hello.
Tracy,
Hi.
this is Katie. I'm getting I'm getting reports that there is no chat box visible. I think that's why you're not seeing that.
Okay, let me
But
try
I think
this.
we can work on that and start Ben's presentation because people can hear.
Okay. Well, all right.
Okay.
Go ahead.
Katie, what's I wasn't exactly sure when we cut out here.
Sure. We were talking about the different responsibilities for the authors.
Okay.
So we were on the slide with the diagram of the structure.
Right. So I think I was just about to just about to wrap up on this slide. I also just wanted to let people know that the roles and responsibilities of each of these different groups and bodies that you see listed here on the slide, including the roles, the different roles of the different tiers of authors, are explained in more detail in an appendix in the report, an appendix called Report Development Process, where there's a lot more detail on all of this. Okay, good to be back. Sorry about that.
Sorry, Ben.
No problem. So next slide, let's go on. So I mentioned the review, the peer review. NCA4 went through multiple layers of federal interagency, public, and peer review via the National Academies of Science. This slide shows 26 points, key milestones in the nearly 3-year process to develop NCA4. There was early scoping and requests for public input in 2016 through Federal Register notices and other means, seeking input on key issues that we wanted to add to or improve upon compared to the last National Climate Assessment, NCA3, in 2014. Some other highlights. So during the late winter and early spring of 2017, a series of regional engagement workshops, I think about 10 or so, and national chapter engagement webinars provided stakeholders around the country with an opportunity to learn about the NCA4 process and also to provide input to the author teams that the authors could take into account before they started writing their chapter. And by the way, for these regional engagement workshops, there was a summary report written for each one. Those are also available online at the website. Also, just wanted to mention that these regional engagement workshops did leverage some existing federal regionally focused programs, such as the NOAA RISA program, the Regional Integrated Sciences and Assessments program. So leverage those existing networks. Other highlights, a third order draft was released in November 2017 for a 3-month public review and peer review by the National Academies. All told, we received over 3,400 public comments. And then the National Academies peer review came in the form of a fairly lengthy report that they publicly released. And then the authors were required to respond to each and every comment. Like I mentioned, the review editors had the job of evaluating the adequacy of the responses to the comments on each chapter. And now the chapter authors' responses to all of these comments are also available online at the website that's in my slides, and I think somewhere in the chat box under the download section. And I think all of that is really important to provide for a report like this with a high visibility it has. This is really important to provide as much transparency as possible. And then a fourth order draft that resulted from those revisions made in response to the public and Academy's comments was then circulated again to the federal agencies for final federal review and clearance. That occurred in April of 2018. And then finally, the final version of the report was released late last year in November 2018. And releasing it then ensured that we adhered to the congressional mandate of producing this national climate assessment every 4 years, not less than every 4 years. Okay, next slide. So unlike the previous national climate assessments, we decided to develop and deliver NCA4 in a staggered 2-part process. And some of the thinking here is consistent with kind of the thinking and the process that's happening at the international level under IPCC, the Intergovernmental Panel on Climate Change. So volume 1 was the underlying foundational climate science. This was called the Climate Science Special Report. It was finalized in November of 2017. It included observations and future projections of physical climate parameters like temperature and precipitation and sea level rise. And then volume 2 addressed the impacts, risks, and adaptation, primarily in the United States, as the result of or in response to these physical climate changes. And it's this volume 2 that was finalized in November of 2018. And this slide also shows how these 2 volumes of the assessment addressed different elements of the congressional mandate under the Global Change Research Act that I talked about earlier. So, for example, volume 1, the Climate Science Special Report, was where we addressed the explicit congressional mandate to provide future projections of global climate change over the next 25 to 100 years. And then, of course, those projections provided a common underpinnings for volume 2. And the idea here was that we wanted all of the sectoral and regional risks and impacts in volume 2 to be using, kind of to the greatest extent possible, consistent baseline information, consistent information about observed changes, consistent information about future projected changes, so that we could provide more of a apples to apples comparison when we're talking about risks in health, risks in transportation, etc. And so that was one of the main reasons why we decided to do this entire assessment in a staggered 2-step, 2-volume process. All right, next slide. Here we have the cover, volume 2. Some other general points. in keeping with the congressional mandate, the National Climate Assessment is policy relevant, but it is not policy prescriptive. So you will not find in this assessment any policy recommendations. It's just not the job of the National Climate Assessment to do that. Now, both Volume 1 and Volume 2 do address mitigation issues and adaptation issues, but not in a way that recommends any policies. We provide science that informs mitigation decisions, and in Volume 2 especially, we show a lot of case studies of local and regional adaptation actions and success stories, but we do not then go on to say, given some of these success measures, the rest of the country should do X, Y, and Z. So again, we're providing information to inform decisions, but we remain very careful not to cross the line into policy recommendations. Again, not the job of the National Climate Assessment. Okay, next slide. So here we have the table of contents for Volume 2 of NCA4. Like I mentioned, we had lessons learned from NCA3 and public comments through early scoping and regional engagement workshops that informed the NCA4 chapter list. Of course, we had to address the sectors as explicitly mandated by the Global Change Research Act. But we also, wanted to address gaps and opportunities to explore new areas, such as the ones highlighted in blue: air quality, international effects. And then in the regional chapters, we wanted to provide a bit more granularity. So we split out the U.S. Caribbean from the Southeast region, this time compared to NCA3. And also compared to NCA3, we split the Great Plains into the northern and southern Great Plains, because in NCA3 you had one big region in the middle of the country that spanned from the Mexican to the Canadian border. And so we split up that region into two. So in the next few slides, I'm going to show some climate observations and projections from that Volume 1, which are also in turn summarized briefly in a chapter in Volume 2, the one called Our Changing Climate, the Roman numeral 2 there. And then I'm going to highlight results from a few of the national sector chapters and a couple of the regional chapters, and I'll also end briefly on some of the adaptation and mitigation issues. One last point, I wanted to add that every chapter, at the end of the chapter, you will find what's called a traceable account. And these traceable accounts are meant to provide, again, greater transparency about the evidence that the authors used to arrive at the major findings and conclusions that are available, that are presented in each chapter. So what's the amount of evidence that we have? What's the quality of evidence? How confident are the authors about the underlying literature? And it's basically the job of that traceable account in each and every chapter to give you more of a sense as to what evidence the authors reviewed in order to arrive at the high-level statements that you find in every chapter. Okay, next slide. Okay, so here, first let's start with observations and the story that NCA4 tells on this. So the physical observations in NCA4 Volume 1, and as summarized then again in Volume 2, paint a compelling picture of a warming world. Observations from around the world show widespread effects of the average warming trend. Just about all indicators here show trends in the directions that you would expect in a warming planet. So high temperature extremes and heavy precipitation events are increasing. Glaciers and snow cover are shrinking, and sea ice extent is retreating. The seas are warming, rising and becoming more acidic, and marine species are moving to new locations toward cooler waters. Flooding is becoming more frequent along the U.S. coastline. Growing seasons are lengthening, and wildfires out west are increasing. Okay, next slide. So here's a focus on global temperature trends. So the long-term temperature observations are among the most consistent and widespread evidence of a warming planet. Since NCA4 was published in 2014, the global long-term and unambiguous warming trend has continued. So what's happened in the last few years? Well, 2016 was the warmest year on record. 2015 ran second, and actually and far surpassed 2014, which is third. And now the full year of 2018, and the year 2018 was not captured by NCA4 because NCA4 concluded before we had the full year's worth of data for 2018. But 2018 is now estimated to be the fourth warmest year on record, according to both NOAA and NASA. So this now means that 9 of the 10 warmest years in the modern instrumental record have occurred since 2005, with the last 5 years, 2014 to 2018, ranking as the 5 warmest years on record. The year 1998 is the only year from the 20th century record among the 10 warmest years on record. So the global average temperature has increased by about 1.8 degrees Fahrenheit from 1901 to 2016. And other point, for short periods of time, say a few years or a decade or so, the increase in global temperature can be temporarily slowed or even reversed by natural variability. Natural variability still plays a very substantial role on short time frames. But over the past decade, a slowdown or apparent slowdown has led to numerous assertions that global warming had stopped. But no temperature records show that the long-term global warming trend has ceased or even substantially slowed over the last 15 years or so. Instead, as just mentioned, the global annual average temperature for the period since 1986 have continued to warm, and according to NCA4, are likely much higher and appear to have risen at a more rapid rate than for any similar climate period, talking 20 to 30 year period, in at least the last 1700 years. So to underscore that the warming trend stands out as large and unusual. Okay, next slide. This is what's happening with the Arctic is kind of becoming an iconic indicator of global change. So as the Arctic warms, sea ice is shrinking and becoming thinner and younger. This left panel with the bars there show how the summer minimum ice extent and average age measured in September of each year. And September is the time of year when the Arctic sea ice extent is at its lowest. So this shows how minimum sea ice extent and average age in September has changed from 1984 to 2016. And then that the bottom left panel shows how September sea ice extent. I'm sorry. These are appearing different from what I had in front of me. The graph on the right is showing how September sea ice extent from 1979, when satellite observations began, to 2016, and the sea ice extent for September has decreased at a rate of about 13% per decade.
And Ben, you have a question. David Wittenberg asks, any explanation or reference links for why, in the graphic on the last slide, certain areas in the southern U.S., parts of the subcontinent, appear to show less of a change? I'm trying to get there. You can
Oh, the south, yeah, the southeast shows that there's been relatively little or almost no warming for the past century or so. And in fact, if you go to NCA4, there's more of a blow up, a more detailed map of the U.S. If I have it straight, the exact mechanisms and the exact reasons for why this particular region is not showing as much warming, I don't think are completely understood, but there is strong evidence that aerosol, human emissions of aerosols, which cause cooling because they reflect sunlight and basically counteract greenhouse gas-induced warming, have been playing a significant role. I think I would have to double check that volume 1 of NCA4 I think provides some more detail about what's happening in that region. But it should be said, using this as an example, that the warming trend obviously is not uniform just by looking at this map. Some regions are warming more than others, and there are some regions, even that North Atlantic kind of blob there in the middle is actually showing a cooling trend, and there are some scientific research into why that is the case as well.
Okay, and then David Reed-Miller points out there are state summaries that might be useful. And Colleen asks, have there been any studies correlating the decrease in Arctic sea ice levels with rising ocean levels?
For any ice in the Arctic that is on the ocean, that sea ice melt will not have any significant change on sea level rise if it's already ice in the ocean, kind of like your ice cube in your water kind of effect. However, there is a lot of land-based ice in the Arctic, as in Greenland, and that melting of that ice on the land is most definitely contributing to sea level rise, and we do have estimates about how much land-based ice melt in the Arctic is contributing to sea level rise compared to the dominant factor of sea level rise, which is just warming waters. Warmer waters expand, but we do have estimates of the relative contributions of Arctic land-based ice melt, thermal expansion, and also glacier melt in other regions of the world outside of the Arctic.
Okay, thanks. And Katie says, David, you might find additional information in Chapter 6. So we'll go back to the presentation.
Yeah, no, great questions. Thank you.
Thank you for your questions. Are you done with this?
Yeah. So next slide, actually a little bit more on the Arctic, just because what is happening in the Arctic is pretty dramatic. So here's another picture of Arctic sea ice extent, but highlighting the trend happening now in 2019. So this is not from NCA4, it's more recent. It's showing that Arctic sea ice extent has been trending at record low pace. I'm talking about this bottom blue line. And that dotted line represents the record low Arctic sea ice extent that occurred in 2012. And then there was a record low extent in September of 2012, which is off the chart, farther to the right, but we're gonna get there. And then this other picture was just from a story that was in the Washington Post, I think, over this past weekend, and I thought the picture was just so stunning and dramatic that I had to show it. And the article there by Jason Samenow from the Washington Post Capital Weather Gang states that in recent days, observations have revealed, as he put it, a record challenging melt event over the Greenland ice sheet, and that Greenland saw temperatures soar up to 40 degrees Fahrenheit above normal last Wednesday. So just a lot of attention is being paid to some of the dramatic changes that are taking place in the Arctic. It is the region of the world. I don't think I mentioned this, but it is the region of the world that is warming most, twice or more than the globally averaged rate. Oh my goodness.
Folks online, we're going to hold all questions till the end because we want our presenter to be able to get through his talk. Thanks.
Okay, yeah. Okay. Okay, so here's about attribution. This is what NCA4 said about the attribution of observed warming to human influence. Of course, both human and natural factors influence Earth's climate. So this panel A shows temperature changes simulated by a climate model when only natural factors, the yellow lines, are considered. And then that black line is what's been observed, the warming trend. And then next panel, B. So this shows simulated changes in global temperature when considering only human influences. And there are both warming influences, the greenhouse gases, but there's also cooling influences, those aerosols that I mentioned. And then jumping ahead to the last, to C. So this panel shows the temperature change simulated by climate models when all factors are considered, both human and natural. And here you see the best match between what has been observed and what is simulated by the climate models. And the conclusion is that the long-term global warming trend observed over the past century can only be explained by the effect that human activities have had on the climate. Okay, next slide. So the last few slides were about observations. Now let's talk about future projections. So early in the NCA4 process, a very deliberate and public decision was made to use widely used scenarios employed by the IPCC process and by the climate community writ large. There's a memo explaining, a public memo explaining our justification. So we decided to rely on what are referred to as the RCPs, the representative concentration pathways. And more specifically, we decided to use what are referred to as RCP 8.5 and 4.5 as high and low future scenarios to serve as framing points for volumes 1 and 2. The numbers 8.5 and 4.5 refer to the additional radiative forcing or heating effect that would occur by the end of this century as a result of human activities. And so for any given RCP, there are multiple socioeconomic and even emissions pathways that could get you to that radiative forcing effect. But 8.5 and 4.5, those scenarios do imply different things. Just quickly, the left panel shows the assumed or implied future global emissions associated with these scenarios. In RCP 8.5, fossil fuel carbon emissions would continue to increase, and then the associated global average temperature on the right side is projected to increase by over 4 to over 8 degrees Fahrenheit. And under RCP 4.5, fossil fuel carbon emissions peak by mid-century, then decrease. And then RCP 2.6 assumes carbon emissions from fossil fuels have already peaked, and the associated temperature increase would be limited to 0.4 to 2.7 degrees Fahrenheit relative to 1986 to 2015. There are some additional reasons for using 8.5 and 4.5, and I think for for time constraints, I'll move on.
Thanks.
Okay, so here are future temperature projections for the United States under RCP 4.5 and 8.5. You can click one, thanks. So by mid-century in the upper maps, and by late century in the lower maps. So regardless of time frame or scenario, you see similar patterns. The largest projected warming is in the higher latitudes. That is consistent with what we're already observing, such as in Alaska, where we are observing a lot of warming, and more warming in the continental interiors, as would be expected. So additional increases in annual average temperature of about 2.5 degrees Fahrenheit are expected over the next few decades, underscore regardless of future emission pathway. And then increases ranging from 3 to 12 degrees Fahrenheit expected by the end of the century. So by the end of the century is when scenarios low versus high really start to depart. But it's in those early decades you don't have a lot of departure, whether you're on the low or the high scenario. So click one, precipitation. So projections of precipitation are much less certain than temperature projections, but the greatest temperature projections are projected to occur in the winter and spring, with similar kind of geographic patterns to observed changes, kind of a lot more kind of increases in precip in northern latitudes, and kind of drying where it's already dry, such as in the southwest. Okay, I'll move on. So there are large projected changes in the number of days exceeding heat temperature thresholds throughout the U.S. So on the left side are projected changes in the number of days, projected number of days above 90 degrees Fahrenheit. So there are projected to be about 20 to 30 more days per year, with a maximum over 90 degrees Fahrenheit in a lot of areas. This is under RCP 8.5, which is with as many as increases of 40 to 50 days in much of the southeast. And on the right side, consistent with warming, there are projected to be 20 to 30 fewer days per year with a minimum temperature below freezing in many parts of the country. Next slide. Sea level rise. I think this is a key area where we made a lot of advances compared to NCA4, where now we have much more regionally specific information. Since the 60s, sea level has already increased the frequency of high tide flooding by a factor of 5 to 10 for several cities. And regional changes in sea level rise and coastal flooding are not evenly distributed across the U.S. Due to a number of factors, including ocean circulation changes, how melting in the poles affect actually some gravitational pull in the water, etc. And let's see. Let me move on. So this next slide here, and the next few, just want to show NCA4 results for specific sectors. And I think it's important to start with human health. It's one of the sectors, as I pointed out earlier, that the Global Change Research Act mandates us to address. Climate change affects human health in a number of ways, alters exposure to heat waves, floods, droughts, extreme events, affects food and waterborne diseases, etc. This slide focuses on projected changes in heat-related deaths in urban areas. So high temperatures in the summer are linked to an increase in risk of a range of illnesses and death, especially among older adults, pregnant women, and children. And then people living in urban areas can experience even higher temperature increases because of the urban heat island effect. And with continued warming, we point out that increases in heat-related deaths are projected to outweigh reductions in cold-related deaths in most regions. And this slide is showing NCA4 results where we had estimates for 49 large cities. So where you see no change, it doesn't mean no effect. It just means those urban areas were not included in the country, and it shows the increases in net mortality in the low versus high scenario. Next slide. So air quality impacts, this is one of the new standalone chapters compared to NCA3. Here we focus on tropospheric ozone or smog. First of all, nationally, ozone concentrations have been reduced by about 22%. Over recent years, this is due to successful efforts under the Clean Air Act. But nevertheless, in 2015, still about 1 in 3 Americans are still exposed to ozone values that exceeded national standards by EPA. Ozone causes a number of heat-related effects, including aggravated asthma, lost days of school, etc. So there is high confidence that climate change will increase ozone levels over much of the U.S., especially over already polluted areas. And in the future, in the absence of climate change, we expect emissions of ozone precursors to come down, but climate change imposes this kind of penalty. So it kind of counteracts the beneficial effects of reducing those ozone precursors. Next slide. Particulate matter is another component of the air quality story. But here we're less confident in kind of the net sign. So fine particulate matter, or PM 2.5, does account for most of the health impacts due to air pollution, and small changes in concentrations can have a large public health effects. But the bottom line is that because particulate matter is very sensitive to weather and climate conditions, including precipitation effects, it is harder to pin down the net effects of a changing climate on PM 2.5 concentrations. It's kind of the bottom line there. So ozone, PM, kind of a different story. Next slide. Food production. So any change in climate poses a challenge to agriculture for various reasons. It can introduce risk of crop failure, affect livestock productivity, affect the viability of pests and weeds, and of course rural communities are especially affected. And so this figure is showing projected changes in kind of a net index of changes in yield of corn, wheat, soybeans, and cotton late into the century. And it underscores that it is very important to take into account the regional effects of climate change. This slide is essentially showing areas that may benefit and areas that may be adversely affected by climate change. There's a host of factors going on, temperature, precipitation, soil nutrients, etc. And it's also very important to consider how adaptation options by farmers and producers will respond to climate change, and how those effects factor into this very heterogeneous regional nature of the problem. Next slide. Coastal areas, really important topic shown by NCA4. A lot of people in the U.S. live now along the coastline, about 42% of the population. on the coastal shoreline. And threats from sea level rise are exacerbated by processes such as high tide and storm surge, erosion, wave, and saltwater intrusion effects. This figure shows that cumulative damages to coastal property across the U.S. Could be significant, but also could be significantly reduced if protective adaptation measures were implemented. The adaptation estimates are the bottom line. Without adaptation, it's the top line. And just to highlight, without adaptation, cumulative damages under the higher scenario, 8.5, are estimated at 3.6 trillion through 2100. It's discounted at 3%, compared to 820 billion in the scenario where cost-effective adaptation measures are implemented. A number of other things to say here, but I'll move on. So this slide shows estimates of monetized damages in different sectors of the U.S. to allow comparisons. This chapter from NCA4 underscores that in the absence of significant global mitigation efforts, climate change is projected to impose substantial damages on the U.S. economy and in key sectors, and that under scenarios with high emissions or limited or no adaptation, some annual losses in some sectors are estimated to grow to hundreds of billions of dollars by the end of the century. So this figure shows that estimated damages for some key sectors, labor, especially outdoor labor, heat-related mortality, coastal property, and air quality, are expected to be among the largest kind of sectors at risk in the U.S. And then the different shadings in the circles show the percentage of the projected damages that could be avoided if the world were to go, comparing if the world were on a RCP 8.5 scenario versus an RCP 4.5 scenario. So that's what's being showed here. Sorry?
That was right, you're going next.
Sorry? Yes, yeah. So I'll just, I know I'm running out of time here.
We can, excuse me, we can stay a few minutes later to finish and for questions if you have time.
Okay, all right. So just last two slides on regions. This is an example of results from the Northeast chapter. Like I said, we had these regional engagement workshops to hear from stakeholders about what was important to them, what is valued in different regions of the country that may be at risk as a result of climate change. One of the themes that is highlighted in the Northeast chapter is the potential for changing seasonality in the Northeast, which is really important to this region's sense of place. That resonates with me coming from Pennsylvania. And under a changing climate, we do expect kind of less distinct seasons with milder winters and earlier spring conditions, which are already occurring. And of course, the changing seasonality can affect the region's rural industries and livelihoods that are so important in this region. Yeah, next. So I also thought I would just shine a light on the Alaska chapter. I did mention that the Arctic is already experiencing some fairly dramatic changes, and the Alaska chapter in particular has a unique story to tell. So the slides here show, first of all, temperature change that is being observed in Alaska, and then in the bottom left two panels show projected changes in Alaskan temperatures towards the end of the century under RCP 4.5, and then RCP 8.5. And it shows just the high level of temperature increases that would be expected. And the Alaska chapter talks about other kind of unique aspects to Alaska that are really important under a changing climate. The effects of permafrost thaw and the implications that has for settlements, for infrastructure, roads, pipelines, and also the story of how indigenous communities in Alaska are already being affected by a changing climate. Less sea ice means more coastal erosion, because with less sea ice you have more wave action on the coastline. More wave action means more coastal erosion. In some cases it means small settlements actually have to relocate because of the changes taking place. So the Alaska chapter really has a lot to say. There is a chapter devoted to adaptation. The authors in this chapter kind of canvassed what's happening in the country and what's been happening in the country since NCA4. The scale and scope of adaptation implementation is increasing across the country, but it's happening. How to compare what's happening across communities is difficult. There are no common reporting systems. Many adaptation actions are not necessarily being labeled as climate change adaptation actions, but we do know enough to conclude that adaptation actions are increasing, but are certainly by no means uniform nor commonplace across the U.S. And then essentially my last slide, technical slide, is circling back to mitigation issue, and this is actually from volume 1, and just to what we say to inform mitigation questions. Wanted to point out that a robust feature of modeling climate change is that there is a nearly linear relationship between cumulative CO2 emissions and global mean temperature, irrespective of the details and exact timing of the emissions pathway. And what this leads to is that eventually stabilizing global temperature, if that is the goal, it requires that CO2 emissions approach zero. So, for instance, for a 3.6 degree or 2 degrees Celsius temperature threshold, or for any desired global mean warming goal, an estimated range of cumulative CO2 emissions from the current period onward can be calculated. And so there is something that folks refer to, scientists refer to as the carbon budget, because you can estimate a range of cumulative emissions that would be commensurate with different future warming stabilization goals, if that's the goal. And if you want to increase the probability that any given temperature goal is reached, would imply tighter constraints on cumulative CO2 emissions. So for any given cumulative carbon budget, if we have higher emissions in the near term, it implies the need for steeper reductions in the longer term. And likewise, if you wanted to decrease the uncertainty of meeting or not exceeding any given temperature threshold, that also implies tighter constraints on emissions. And the very last slide, here's a good picture of the one time that not all, but just a lot of the authors got together for one meeting. Again, this was a big group effort. Like I said, about 300 or so federal and non-federal volunteer scientists were part of this really massive effort. And also just really want to point out, let's see, it's not shown here, but the website for NCA4, I have to say, is really great. And the staff at USGCRP and NOAA's technical support unit located in Asheville, North Carolina, did just a tremendous job on this website. And I would encourage folks go to it. It is very searchable. It is very modular. The language throughout NCA4, I think, is highly accessible to a range of audiences. This website, as with other kind of elements of NCA4, I think provides for also a very transparent report. If you like a figure in NCA4, you can click on the figure and see what's behind it and get the data behind it, see what's underlying it. So the website is really a great product that I know that the team should definitely be proud of. So I know we've gone a little over.
That's okay.
I'll end there. Thanks everyone for joining.
Thanks, Ben. We have a few questions. Katie's tried to answer several of them. And just kind of looking from the top, Claudia is going to be addressed with, Katie's going to send her some stuff. David Wittenberg, yeah, that they were addressed. Colleen, has there been studies correlating oh, you addressed that, yep. And Chuck added some additional information for Colleen about some NCAR work. Are the slides available? Yes. Alicia asks, is the human health slide at the end of the century projection? So the human health slide, it's this one. Let me see, I saw that one right there.
With the, I think it is. Yes. Yeah, I'm sorry. Yeah, I'm sorry. I just realized that I don't have a time frame on there, but it is by end of century.
Okay, great. And then Joel Smith says, what scenario is being used in the agriculture feature? In the agriculture figure, I guess he means like 8.5 or the food production.
RCP 8.5.
Okay.
Is that one.
For the food, okay. And then Barbara Mayer comments, sure wish Hawaii and Alaska were shown in many of these slides, but we kind of get used to that. Are they identified in the report at all, Ben?
Oh, absolutely. I mean, for brevity, I could only show so much. But if you go to the table of contents, I mean, I did have the standalone Alaska slide, and Alaska is a standalone chapter.
Right there.
Right? Go back. So we also have a standalone chapter, Hawaii and U.S. affiliate Pacific Islands. Sorry, I didn't get to any of that in this talk, but we most definitely have a dedicated chapter to that region.
Okay, sorry. And then let's see, Barbara Mayer. Oh yeah, Eric asked about the slides. Katie answered. Let's see if there are other questions. Alan Biddlecombe asked, with respect to food production slide, is there a similar graphic for Central and South America in any reports or presentations?
Offhand, I don't know. I imagine there is. I'd point you to IPCC Working Group 2 that has regional impact information around the world. I would go there first. If you can't find anything there, contact me. I'll help you out.
All right, and Mary, many thanks. And Mary Lazarus says, thanks for the overview. So much important info. Good to see the state summaries. Will those be kept up to date?
I think the short answer is yes, periodically.
Yes, periodically. Okay. Rand says, thank you. Will I find the graph that was shared in that location? Yes, all those should be shared. David Reed Miller says, Mary, the state climate summaries, NOAA is in the process of updating them. You can see them on the website linked above, which has already been updated.
Thanks, David.
Yeah. And I think that's all the questions. Lots of comments, great effort, and thank you. Any last comments, David? Ben, looking at this, sorry.
No, just really appreciate the opportunity to kick off this webinar series and represent really the whole team for this. I hope I did it justice.
Yes, and you can see Ben's email there. It's bendeangelo@noaa.gov if you have any questions. And Katie, maybe you could add your email in case people have questions about the seminar series. And Stephanie Miller says, grateful for all the work. Thank you again. Andrea comes, Katie's providing your email in case anybody would like to contact her directly. All right, well, I think we've wrapped up. I'm sorry again about the loss of connectivity. I really can't do anything about that, but thank goodness it only happens about once a month. So thanks for joining us, everybody. Andrea, did you have one last comment? Thanks, Michael. Thank you, Ben. I know you're busy.
Thank you.
All right.
Thanks
Everyone.
This was
Thanks
really
for coming.
interesting.
Bye-bye.